Namaskar, welcome to the CTET session 2 of mathematics. I am Manohar, Senior Research Fellow, Department of Education, RIU Mysore. So in the session 2, we will be discussing about LCM and HCF, more about the applications level and word problems we are trying to solve in this session. Okay, so moving to the next session objectives. By the end of the session, you will be able to understand the concept of LCM HCF mathematical relationship. In the previous session, we have seen what is the HCF and what is the LCM and how we can calculate LCM and HCF through various methods, like factorization method and division method. So in this session, based on that concept, we are trying to see the relationship between the LCM and HCF, and then we also look at CTET. Most of the questions will be asking from this chapter, giving the word problems and how the concept of HCF and HCM we need to apply in this word problems. Okay, so that means we are trying to decode the word problems by using the keyword triggers, by applying the HCF and choosing whether we need to apply concept of HCF or concept of the LCM. Okay, then we also apply LCM and HCF concepts to fractions and decimals. So that means whenever they ask the questions in the fraction form, decimal forms, how we can identify, apply this LCF and HCF concept and try to find the answers. Okay, so this is the session objective of the session 2. Okay, so then coming to the question 1. So this question is asked in the January 22 in the CTET paper 2. Which of the following statement is not true? Okay, so there is a question like this: which of the following statement is not true? And there are 4 options as given. The option 1 is HCF and LCM of XY are 15 and 120. And the option 2, HCF and LCM of XY are 20 and 250. And the option 3, LCM and HC of XY are 70 and 14. Option 4, LCM and HC of XY are 290 and 58. So when they give this kind of question, so how we need to solve this question? Okay, so they're asking, there are 4 options that are given, and we need to identify out of all these 4 options which statement is true and which statement is not true. How we can identify this one? Let us see. Okay, so now what is the concept which is involved in the question in order to identify? So the question, the concept is the LCM of any given set of 2 numbers is always exactly, it must be divisible by their HCF. So that is the concept which is given in the previous question. So if you look at the options, there are 2 numbers which are given, that is the HCF and LCM. Okay, and we need to see that the statement, given statement, whether it is a true or not. Okay, so that means any given set of 2 numbers is always exactly divisible by their HCF. Okay, so when we do this one apply, so that means we are trying to divide LCM divided by with the HCF, so which comes the whole number. Okay, why? Because the HCF always contains the lowest common powers of the prime factors and the LCM always contains highest powers. So that means LCM is having the highest powers of the given number and HCF is having the lowest powers of the given numbers. Okay, so for example, let us take the numbers as given like this, 12 and 18. Okay, so we need to identify HCF and LCM and we see the relationship of this one. Okay, now how we can identify the LCM? Okay, through the factorization method. Now let us take the number of the 12. Okay, so what are the factors of the number? Factorization of the number 12 can be written as 2 to the power of 2 into 3. Okay, so 18 can be written as 2 into 3 to the power of 5. So which we have discussed in the previous session. So like that we can see. Okay, so and then out of this, now let us see what is the HCF of highest common factor of 12 and 18. Okay, so now what we are saying, that remember that HCF means we need to see the lowest. What we have to see? You have to see the lowest powers. Okay, out of this 12 and 18, what are the lowest powers here? Can you tell me what is the lowest powers? So 2 is nothing but 2 to the power of 1. 3 is nothing but 3 to the power of 1. Okay, so that means 2 to the power of 1, 3 to the power of 1 are the lowest powers of the numbers of the factors of the 12 and 18. Okay, so 2 to the power of 1 nothing but 2, and 3 to the power of 1 is nothing but 3. Okay, so when we will multiply 2 into 3, we will get the 6. This is our HCF. Okay, highest common factor of the 12 and 18. So now LCM. So the LCM means we need to remember that highest powers. So from the obtained factors, we need to see what are the highest powers of the given numbers. What are the given numbers? Say 12 and 18. Okay, so we got the factors of 12 and 18. So what are the highest powers are 2 to the power of 2 and 3 to the power of 2. So we have only two powers, 1 and 2. So 2 to the power of 2 and 3 to the power of 2 are the highest powers of the given number here. So now 2 to the power 4 can be written as 4 and 3 to the power 2 can be written as a 9. Okay, so that is when you multiply, simplify this one, we'll get 9 4s are 36. Okay, so now we got it the HCF and we got it the LCM also. Now what is the rule we need to apply? See, the LCM of any given set of numbers is always exactly divisible by their HCF. So now what is the LCM here? 36. So 36 always divisible by the HCF, the obtained HCF. What is the HCF here? 6. 6 ones are 6 6 are 36. This is the whole number. So this is the concept which is applied in the previous question. Now let us try to solve that problem. Okay. So now the question is, which of the following statement is not true? Okay, so the option 1 is LCM of 120 and 15 is divisible by their HCF, and LCM of 250 and 20 is divisible by their HCF, and LCM of 70 and 14 is divisible by their HCF, and LCM of 290 and 50 is divisible by their HCF. Now options are given, we need to check each option. Okay, so let us take the statement 1. LCM of 150 is divisible by their HCF. Okay, so now there are two numbers which are involved here, 120 and 15. Now how can you say that which is the LCM and which is the HCF? So let us go back to them. So HCF means he is having the lowest powers. Okay, HCF means highest powers. Okay, so now 15 is the least number, so that becomes our HCF, and LCM maximum number will become the LCM here. Okay, so now 120 divisible by, so what is the formula we are applying here? LCM divided by HCF, that gives the whole number. Okay, that is the formula which we are applying here. Now LCM is in the option 1, 120 divisible by the 15. So does this statement is true, which is satisfying in this formula? Yes, of course it is satisfying. Now 120 divided by 15, if we say 15 8s are 120. Okay, so if you simplify this, we will get the answer is right. So that means it is exactly perfectly divisible by the 15. Okay, now option 2, if you see LCM of 250 and 20, it is divisible by their HCF. Okay, now so similarly apply in this formula. So what is the LCM here? 250. When you divide 250 by 20, we will get the 12.5. Okay, let us see that whether 12.5 is a whole number. It's not a whole number, so therefore it is not a true. Okay, 250 is not perfectly divisible by the 20. Now option 3 is, look at LCM of 17 and 14 is divisible by the HCF. Okay, so now 70 is the LCM and 14 is the HCF. When you simplify this, we will get the answer is the 5. Okay, so that means 70 is perfectly divisible by the 14. Okay, so now 290, option 4, if you see LCM of 290 and 50 years, it is divisible by their HCF. We need to check whether it is 58 is 290 is exactly perfectly divisible by the 58 or not. Okay, now when you divide this one, okay, when you simplify using the division method, if you see that it is divisible with the 5. Okay, so that means this is also statements are those. Now all this statement 1, statement 3, statements 4 are the true. Okay, which is satisfying in the given condition divisibility rule of the LCM and HCF. Only the statement 2 which is not satisfying, that is LCM of 250, when it divisible by this 250 and 20, it is we are getting the fractions of fraction in the form of the fraction, therefore it is not a whole number, so therefore this condition is not satisfying. So there you can say that option 2 is the correct answer for this question. So we have to see the question which is not the true. If you ask the true, which are the following statement true, if they ask which are the statements are true, then we say that 1 3 4 are the true, but we have been asking which is not the true, so therefore option 2 is the correct answer. Okay, so now the LCM of 250 and 20 is not exactly divisible by their HCF, so LCM must be exactly divisible by HCF. So this we have to remember all the point, because HCF is always contains multiples of the LCM. So now the second question, if you look at HCF of two numbers is 28 and the LCM is 336. If one number is 112, then what is the other number is? Okay. So look at the question here. Option 1 is 56 and option 2 is the 70, option 3 is the 84 and option 4 is the 98. So what they are asking, they are trying to find out, we need to find out the other number. One number they have given, okay, the HCF of two numbers, we don't know, that is X and Y, okay, is 28 and their LCM is 336. Okay, so one number they have given 112, then what is the another number? So that we need to identify. Let us see how we can identify this and how we can solve this question. Let us see now. So what is the concept which is involved here? That is a concept which is involved. Okay, the relationship formula, HCF, LCF, the relationship is involved in order to solve this formula. Now first number, okay, the relationship is like for any given two numbers. The first number into second number, it will becomes LCM of that number and HCF. Okay, so that means if you consider first number is A and the second number B, so the LCM of AB into HCF AB is, it looks like this. We can apply this formula. Okay, so this formula only work when we have the two numbers, not more than the two numbers. If we have the two or more than the two numbers, we cannot apply this. So therefore it only applicable only for the when we have the two numbers. Okay, this is the concept which is involved in order to solve that formula. Okay, so that means we are trying to see the relationship of HCF and LCM when they give the two numbers of LCM and HCF and one number they again we need to identify which is the another number we need to identify. Okay, and then so now so let us look at now, let us try to solve this problem. Okay, the HCF two numbers is 28 and their LCM is 336. Okay, if one number is 112, then other number is what? Okay, so let the number be, we don't know what is the number, second number, we let it be B. Let us consider that it is a B. Okay, the first number they have given that 112. Okay, 112 into B. I mean, we're trying to put it, in the form of previous formula which we have discussed. That means A into B is equal to LCM of that number and HCF of that two numbers which I have given. So 112 into B is equal to 28 into 3. That is it. When you calculate this one, okay, we get the, so we don't directly do not calculate like multiple large numbers. Instead of that, we try to simplify like this in the form of. So now B is equal to 28 336. The LHS side of 112, bring it to the right side, becomes a division. Okay. So now this 112 exactly goes into the 3 times of the 336. Okay. Now even if you find the difficult, you can see the unit here. Okay. So which is the number nearest number trying to divisible here. So 2 and 2 3 is okay. So therefore like that we can think and solve the simplify the formulas. Now if we get, okay, this will become a 3 times and then we'll get 28 into 3. So when you simplify this one 28 into 3, we'll get the 84. So what is the correct answer is here? 84. Okay, so that means what is another number? One number is the 112 and another number is the 84. This is the correct option for this question. So which is a very easy question, which we need to understand, recall the formula which when they ask like when they are given HCF and LCM of that numbers and when they give one number and what is the another number. If they ask you to identify what is the another number, simply apply this formula and you will get it the answer. Okay, so then moving to the next one, there are another question like this. A shopkeeper has 75 gold and 120 silver coins. She wants to stock them so that each stock contains the same number of coins of the same type. So the maximum number of coins that each stock can have is, whether it is a 5, option 1, and second option is 15, third option is the 10, and the fourth option is the 25. So the question is that she has the 75 gold and 120 silver coins. So when they equally she arrange, like she wants to arrange the stocks stocks equally. So in such a cases, the number of coins of the same type, how many is required? Okay, so the maximum number of coins that each stock can have is we need to identify. Okay, so let us see how we can identify what is the concept which is involved in order to solve this problem. Okay, so let us try to understand the concept first. Okay, now before understanding, so that means see if you look at here, so the question is given in the form of word. And we need to see that, read and try to understand that whether we should apply HCF or LCM, okay, in order to get the solution. Okay, so that is what. So how we can identify that, whether we can apply HCF concept or LCM. Let us see now here. Now, in order to identify whether it is a HCF, whether we need to identify, find the HCF in the given word problems, we have to see some of the keywords like this when they mention in the question, like grouping and dividing and cutting and stocking, keywords like maximum, largest, equal stacks. Okay, when you see these kind of words, and okay, when you see these kind of words, that means we try to understand that we need to apply the highest common factor which we need to find out, that is the maximum or largest or equal stacks. Okay, so that means we are breaking a large amount into smaller equal chunks. Okay, so they are trying to do the decomposition of the here. Okay, so now for example, divide 70 books, 75 books into the maximum number of equal parts. Okay, so then second example, like cut a chocolate bar into the largest possible equal pieces. Stock 75 gold coins so that each stock has the same number of the coins maximum. Okay, so when you see in a word problem these kind of words, we need to immediately try to see that we need to try to remember that we need to apply the HCF, highest common factor. We need to do that. Okay, of the given numbers. Now similarly, when to find the LCM. Okay, now whenever they give in the word problems, but try to see that words like recurring events and meeting points and synchronization and together minimum least number. When they ask you to identify the least number, when they ask to identify what is the minimum value, when they ask to identify what is the together of those, okay, when asked to identify the recurring events, meeting points, okay, then we need to apply the concept of the LCM. So that means we are scaling up to the future point where things coincides. Okay, so in such a cases we need to apply the LCM. In these cases we need to apply the HCF. Okay, so for example, let us see two machines run every 6 and 8 days. Okay, when will they run together again? So that's when they ask the together. Together means we need to apply the concept of the LCM. Here maximum we need to apply the concept of the HCF. So like this, events happen every 4 days and 6 days. After how many days will they happen together? Okay, so that means we need to apply again concept of the LCM. So two friends meet after 12 days and 18 days. When will they meet on the same day again? Same day. Okay, so these are the keywords which we need to remember always. Okay, so in such a cases we need to apply these cases, we need to apply the LCM. Now let us go back to the previous question. So what they are asking here, a shopkeeper has the 75 gold coins, 120 silver coins. So he wants to stock them so that each stock contains the same number of coins of the same type. Okay, so what is the maximum number of coins that each stock can have, whether it is a 1, whether it is a 15 or 10, 25, let us see now. Okay, so now what is the keyword? Try to identify what are the keywords. She is telling that, okay, stock, and what is another keyword here? Maximum number of coins that each stock can have is, so that means number of more number. Okay, so that means, so go back to the here, maximum means what is the concept which we have to understand, we have to apply. Maximum means we need to apply the concept of the LCM. Now let us try to apply the concept of HCF concept. Okay, so that means we need to divide the coins equally. Okay, to divide the coins equally we need to find out what is the common factor of the given numbers. Now we need to identify HCF 75 and 120. Okay, so what is the HCF common factor of 75 and 120 is 15. Okay, 75 can be written through the factorization. We can write it as 3 into 5 to the power of square. Okay, so this we can do 325 is 75 and 25 we can write it as 5 into 5 25, and then 5 again you can write as divide with the 5, remainder becomes 1. Okay, similarly for the 120, 260s are 120, 230s are again 60, 230s are 60, and again 250s are 215s are 30, and then again it cannot be divisible by the 2. Let's go for the check for the 3. 3 5s are 15 and 5 1s are 5. Till the remainder 1 comes, we need to the division. Okay, so now try to identify in the 75 whether the divisors are there here. 3 5 5. How many times 5 is there? 2 times. So therefore 3 is the 1 time, 3 to the power of 1, 5 is the 2 times, it is divisible, 5 to the power of 2. In the similar case 120, how many times we divide 120 with 2 to the power of 3 times. So there are 3 times we have used here. 2 to the power of 3 into 3, how many times? 1 time. 5 how many times? 1 time. Okay, so now what is the common bases are 3 and 5. Okay, so which are the common here? 3 and 5. 2 is not the common factor here after both the numbers 75 and 120. So the common bases are 3 and 5, and what is the, so when you see the 3 and 5, what are the lowest powers here? 3 is nothing but 3 to the power of 1, and 5 is nothing but 5 to the power of 1. These are the lowest powers of the HCF 75 and 120. So therefore when you simplify this one, you will get the 15. Okay, so that means what is the answer here? Option 2 is the 15 is the answer. Okay, so when they ask the maximum, means we need to apply the concept term. Simply we need to apply the concept of the HCF, and then we can be able to solve this problem. Okay, so what is the maximum number of coins that each stock can have? Only 15. Okay, let us go to the next question. Now this is also one of the important question, very frequently now in the CTET for paper 1, paper 2 they are asking. So the similar this kind of questions are nowadays focusing more. The question is like this: let x be the least number which when divided by 8, 12, 20, 28, 35, which leaves a remainder 5 in each case. What is the sum of the digits of that x, which we need to identify? So what it is trying to say, that asking, what is trying to ask, let x be the least number. We don't know what is the x, okay, number. So it is there in the options which we need to identify. Which when divided by 8 and 12, 20, 28, 35, the remainder will leave the 5. So that means we will get the remainder 5. Okay. So now let us see which concept it is involved and how we can solve this one. The concept which is involved in this problem is with the reminders. So when asked for the least number divided by ABC, that leaves the same remainder in each case, we need to apply the only 2 steps which we need to apply. One is that first thing is we need to identify the LCM of given numbers. Okay, so whatever the numbers ABC, numbers like 5, 8, 10, 12, 20, like, okay, so whatever the numbers, for that we need to first identify the LCM. So once you identify the LCM, add the remainder, then you will get the least number required. We don't need to much complete solution. You have to require. If you just identify the LCM and add the remainder, then the number will get the required number. Okay. So for example, let us take, find the least number which when divided by 8 to 12, 20, which leaves the remainder 5. Okay. In the step 1, what we have to LCM of we identify the LCM of 8, 12, 20. Okay, so when you identify the LCM of 8, 12, 20, we'll get the 120. So this we can through either factorization method or we can through the division method. Okay, so we got the LCM of 3's number is 120. Now what we have to add the 5. So 120 plus 5 equals 125. Least number is the 125. Let us see. Okay, for this. Now let us try to solve that one. Okay, so let x be the least number which when divided by the 8, 12, 20, 28, 35, which leaves the remainder 5 in each case. So what is the sum of the digits of the x we need to identify. Now I have done for this here LCM of 8, 12, 20, 28, 35 of these numbers. Through the division method, we can identify that we can do the division method, okay, by checking with the 2, 3, 4 like tables. Okay, so when you see that one, we will get the final LCM is the 840. Okay, for division method the LCM is through the division method it is the 840. Okay, now once we get the 840, the LCM we got it, and then we need to apply the add the 5. Okay, so that total will get the 845. Okay, least number is equal to LCM plus the remainder. So now what we are asking, we need to identify the sum of the digits of this x. Okay, so what is the sum of the digits of the x? So that means what we need to do, 8 plus 4 plus 5. So when you do that sum, you will get it the 7, which is the option correct here in the here options. If you look at the option 1 is having the 17. Therefore option 1 is the correct answer for this question. So only simply what we need to do when you have this kind of questions, we need to identify the LCM of given numbers. Once we get the LCM, we find out the LCM through the factorization method or division method, whatever the method it works easy for you, and then add the remainder for that. Okay, so when you add the remainder, we will get the sum of the product, we will get answer. For that we need to see that do the sum of the obtained answer, then we will get the solution. Okay. Next question. The least number which is a perfect square and it is also divisible by the 10, 12, 15 and 18 is. Okay, so there are the 4 options are given. Let us see that what they are asking here. The least number which is a perfect square. We don't know what is the least number, but that is a which is a perfect square, okay, and then it is also divisible by the 10, 12, 15 and 18. So that means out of these options, one is a perfect square which is divisible by these four options 10, 12, 15. Now let us see which is the concept which is required. Okay, so the logic here which is involved, the number must be multiple of the LCM of the given numbers. So whatever the numbers they are given here, that must be the multiple of the LCM of the given numbers. So what are the numbers that are given? These numbers. So this should be the multiple of that number. Now what we have to do, find the LCM of given numbers and then factorize, find the prime factorization of the LCM through the prime factorization. Then check for the pairs. Okay, for a perfect square, every prime factor must appear in a pairs, even pairs. Okay, so like whatever the pairs they have given, it must be equal to it should be even. Okay, if it is not even, then we also again we have to make it into even. So make all powers even. If any prime factor has an odd power, okay, then multiply the LCM by that prime factor to make its power even. So that the required number is equal to LCM into product of missing the factor to make it a power even. So that means whenever you get the power is even or like 1, 3, 5. Okay, so for this again what we have to, we need to add that number and then we have to make it into even number. Okay, so that is the idea which is involved in order to solve the problem. So for example, LCM of 2 to the power of 2, 3 to the power of 1, 5 to the power of 1, 3 is unpaired. Okay, so multiply 3. Okay, 2 to the power of, so now it is a smaller here 3. Okay, so for this concept what we have to do, we have to 3 to the power of 1 again you multiply with the 3, so therefore it becomes making into even. Okay, so this will become a perfect square. Okay, first find the LCM, then check its prime factors to be a perfect square. Every prime factor must exist in the pairs, even pairs. Okay, so multiply the LCM, whatever factors are missing the pair, then we will get the solution. Now let us try to see that. Okay, apply this concept in this. So the least number which is a perfect square and it is also divisible by the 10, 12, 15, 18 is. Okay, now find the LCM of 10, 12, 15, 18. So through the prime factorization we can say that, okay, 10 can be written as 2 into 5 and 12 can be written as 2 to the power of 2 into 3. Okay, through the factorization. So then 15 can be written as 3 into 5 and 18 can be written as 2 into 3 to the power of 2. Okay, so now what is the LCM product of the highest powers here? So when you look at here 2, okay, which is the highest here, 2 to the power of 2 and 3 to the power of 2 is the highest, and 5 if you look up 5 to the power of 2. Okay, so now if you solve this one, we will get the answer is the 180. Okay, so now what is the LCM of 10, 12, 15 is, so the LCM we will get the 180. Now what we have to find factors of 180 we need to identify. Okay, check the pairs. Okay, 2 is the even and 3 is the even, 5 is the odd one, 5 is not a paid here. Okay, so now what we need to do, we need to multiply to make it a perfect square of the 5 one, multiply the missing factor 5. So what we have to multiply with the 5. Okay, so then it becomes a 900. Now we have to check whether this 900 is a perfect square and divisible by all these numbers or not. So 900, of course we can write it as of course it is a perfect square. So 900 can be divisible by the 10, it can be divisible by 12, it can be divisible by the 15 and it can be divisible by the 18. It all gives the remainder 0. So therefore we can say that option 2 is a correct answer for this kind. So first we identify the LCM. Okay, then after identifying the LCM, for that prime factors of identify the prime factors of 188 and check the pairs. Okay, whether pairs are even or odd. Okay, so if it is odd, then what we have to the missing factor we need to multiply. So okay, so that means for whatever the LCM we got, for that we need to multiply with that missing factor. Okay, so then after once you get the number and then that check the value whether it is a perfect square and it is divisible by the given numbers or not. Okay, so once we perform like this, we will get the solution. Okay, so in this case we got it the 900, which is obvious. Of course it obviously it's a perfect square which is divisible with 30 into 30. Okay, that is what this is where we can solve this question. Okay, then in case there are some of the questions frequently again they're focusing on where they're giving the fractions and decimals and asking to apply the concept of the HCF and LCM. Okay, for the fractions like A by B, they're asking the concept formula which we can do. HCF the fraction, in order to identify the highest common factor of the given fractions, we need to identify the first HCM of HCF numerators, highest common factor of the numerators, and LCM of denominator. Okay, least common multiple of the denominators. So for example, let us see, find the HCF of the given two fractions here, 3 by 4 and 5 by 6. Okay, now what is the HCF numerator here. What are the numerators? 3 and 5 are the numerators here. Okay. Now 5, highest common factor of the 3 and 5 are the only 1. Because why it is a 1? 3 can be written as 1 into 5 can be written as 1 into 5. It cannot be divisible with any other number. Similarly, LCM of denominators, let us look at these are the denominators 4 and 6. So 4 and 6 LCM is, it becomes a 12. Okay, so therefore HCF, what is the HCF of the given fraction becomes a 1 by 12. Okay, always reduce the final fraction into simplest form. Okay, so this is a one way of when they give the fraction, we need to solve, apply this formula and solve the answer. Similarly, for decimals, convert the decimals into fractions, then apply the fraction rules here. So for example, if you see 3.6 can be written as 36 by 10 and 7.5 can be written as the 75 10. So again, if you simplify this, you will get the same answer only. So therefore, for our convenience, we are converting the decimal into in the form of fractions, where you can apply this formula and find the solution here. Okay, so ensure all the denominators are equal before solving. So convert all decimals into the fractions with no decimals in the denominator. So denominator must be always with numerical number. It should not be not be having any decimal points. Okay. That is the one thing which you have to be remembered. For fractions, HCF is equal to HCF numerator and LCM of denominators. For the decimals, we need to convert the fractions first, then follow the same fraction rule we need to follow. Okay, so this is the in this session which we are discuss as of now. So always check the options. Sometimes only option is the divisible by the HCF. Okay, so don't multiply completely. Use the fractions to cancel out large numbers like in the golden formula. Just apply try to identify which is the required number. Only that number only we try to identify the first. Okay, so look at remember the keywords when they give the word problems like for the HCF and LCM, and when they in the word problem they give the questions hidden concept of HCF and LCM. Now try to remember the words like keywords where when to apply the HCF and when to apply the LCM. So for examples like stacking, grouping, equal piles, when you ask these kind of things, we apply the HCF, and tolling bells together meet again, these kind of words when you see in the keywords, we try to apply the concept of the LCM. Okay, so yeah, so what we have discussed in today's session, in the session 2, we discuss concept of fractions and decimals. We try to see the mathematical relations of LCM and we try to see the keywords of when to apply the HCF and LCM when they give the word problems. So keep all the practice and remember all the formulas and try to solve all the previous questions. Thank you.